Welcome to Study Loop.
Hello, in the question we have given that some amount of ideal gas with internal energy U and initial temperature of 100 degrees Celsius. So internal energy is given, that is U, and the initial temperature. So let us call Ti as the initial temperature, which is 100. Let us call T1 as 100 degrees Celsius. So it undergoes an isobaric expansion. So it undergoes an isobaric expansion. So the process is isobaric. Process is isobaric. Isobaric means pressure is constant. So that its volume doubles. So let's say initial volume is V1, or say just V, or V1 is the initial volume and V2 is the final volume, which is 2 times of V. This is what is given in the question. So we can say that the internal energy of this gas after expansion in terms of U is. So we have to tell what will be the internal energy after the expansion in terms of U. Now see, one relation which we have is of internal energy, U is equal to F divided by 2 in RT, where F is degrees of freedom. So it depends on the system. If I have a single monatomic gas, the degrees of freedom is 3, and so on. So we have this formula of internal energy. So this is the formula for the internal energy, which we get by solving the equipartition theorem. So now this is the thing. So from here we can interpret that this U, internal energy, is directly proportional to temperature. But now there comes a question. There is nothing given in of temperature over here. Just T1 is given to be 100 degrees Celsius. So we will find out T2. So we will just find out T2 and then see what is the temperature. So now initially say the it is U. So initially we have this internal energy to be U. Then finally at some temperature, so the temperature will increase, and after increasing the temperature, this will also get affected. So now let us see what happens. So let us write the ideal gas equation, because they have mentioned that we have the ideal gas. So ideal gas equation, so we have ideal gas equation, that is PV is equals to RT for 1 mole of gas. So from here pressure is constant. So V by T are variable, so that is equal to R by P. Now R by P, R is itself is a constant, and as this process is isobaric, so this P is also constant. So this side is a constant. So V by T is a constant. So this is nothing but our Charles law. So now can I write then V1 by T1 is equals to V2 by T2. So if I can write this, now V1 is V, T1 is 100. 100 plus 273, we can do that, but I just want the temperature dependence. So I will just put here 100 is equal to V2. V2 is 2 times V divided by T2. So this V will get cancelled, and what I will get from here is T2 is equal to 2 times of T1. If I just put here T1 itself, so I will get 2 times of T1. So that is 2 into 100, which is 200 degree Celsius. Or if I just put T1, or if I just put T1, then I will get T2 is equal to 2 times of T1. So I'm just telling this. Now coming back to our equation, so U is directly proportional to T. So initially it was temperature T, so the internal energy was U. Now the temperature has become T, 2T1. So here the internal energy was U. Now temperature is twice of T1. So internal energy will be directly proportional to 2 times of T1. So the internal energy will get doubled. So the internal energy will be internal energy will be 2U. So this is what we get. So this is the answer. I hope you find the solution useful. Thank you.